Hi guys, and welcome to a mini-series that I like to call Types of Functions. In this mini-series, we're going to learn about what are functions, we're going to learn about function notation, and then we're going to talk about some specific parent functions and characteristics that they have. So let's start with, what is a function? What makes something a function? Now, I like to relate everything back to life. So I'm married, and I like to think that our relationship is a functional relationship. And of course, there's going to be a lot of components that go into something that makes it functional, but let's just get down to the bare bones. The thing that makes our relationship functional is that there is one wife and one husband. He is not going out with other girls, right? I am the only girl. So, the way that we would talk about that in math terms is for every x value, there is only one y value. For every husband, there's only one wife, right? And it doesn't have to be husband and wife. It can be any sort of relationship that you want it to be. But for every x value, there is only one y value. That's what makes something a function. Now, if you think about time, because again, I love relating things back to life. If you think about time could be a function with place. You cannot be in more than one place at a time. I'm not talking about straddling over state lines, right? You're still in that one location, even if it happens to be two states, because you're straddling a state line. You can't be in Florida and Washington at the same time. It doesn't work. That defies, well, more than just physics. It defies a lot of things. So a function is something that for every x value, for every input, there is only one output. There's only one, I spelled that wrong. There is only one output. So a function could look like a line. A function could look like an exponential curve. A function could look like a parabola. And any one of those are functions because as you look at the x values, there is only one y value. So right here at this x value, there is only one y value. You will not see a different y value at that time. So that's what makes it a function. A quick and easy way to tell if something is a function is something called the vertical line test. And if something passes the vertical line test, that means you could draw a vertical line and it will only cross your function in one place. If it crosses your curve in more than one place, then it is not a function. So that's what makes something a function. Okay, let's talk about function notation. Function notation allows us to identify what is the output and what is the input. So our output is f of x. Our input is the x. That is what we are going to input into the equation. But f of x is what is the value at that x. So what is the value at that x? And so if we're looking at this green graph here, let's say that's 1 and let's say this is 0.5. We could say that at f of 1, the value is 0.5. So whenever you have something like that, the function notation would say take whatever is in that set of parentheses and plug it in. So that's our input. We also call that the argument. We also call that the argument. And so sometimes you might hear the argument of this is x. This is read a couple of different ways. F of x or f at x. It is not f times x. It is not f times x. Now, it doesn't always have to be f. F means function. But sometimes we're talking about specific things. Let's say we wanted to know the height of a function at a specific time. We could use h of t, telling us that our input is time, but our output is going to be the height. Or velocity at a given time, v of t. So it doesn't have to be f. It can be any letter that represents your function. In the next video, we're going to start talking about some specific functions.